Okay, I'll talk today about geomatics engineering. It's my major, and I was shocked when I first talked with people, and many people don't know about my major, and that's why I wanted to make it known. First, I will talk about introduction, then GIS, photogrammetry, remote sensing, survey, and finally GPS. Okay, what is geomatics engineering? Geo, it refers to the earth, and matics, it's to mathematics. Then it's measurement for the earth. The mathematics of the earth, the science of the collection, analysis, and interpretation of data which is related to the earth's surface. Then first one is GIS, and it stands for Geographic Information System. Okay, what we need for making projects or systems? We need first people, software called GIS. Then we need printed maps and database. How can we find printed map and database? We should go to the field and draw the maps and bring the data. Then the GIS can be defined as system for capturing, storing, or checking and analyzing the data, which is related to the earth. Okay, I used to work in this in GIS, and I want to obtain my master degree in the same department. First, I want to explain the layers and what it's important. When we take the information from the data from the earth, first we need to organize it as layers. For example, if we have a city, we can put the first of the street as a line here, polyline. Then the buildings, we can put it as a polyline, and the end point of interest, we can put it as points. At the end, we can have like this, a city, real city in 3D model. GIS can design our future by make everything digital, and you can make many analysis on that. My final project for graduate, it was for the city, base map for the city in my country, and the pipelines for water network. And if I have a problem in some pipes, how can I bring another line to bring the water to these buildings? Okay, photogrammetry. The science of making measurement from photographs taken from aircraft. Then the output from the photogrammetry is maps and drawings and measurement or 3D model. The most important one is the 3D model, and I'll explain more about that. Maps today, we use the maps for everything, and that created by photogrammetry, most of them. Then overlapping. I will talk about overlapping. What is overlap and what is the percentage and what is important. First, what is the overlap? It's to take two pictures for the same area, but with different angle. Like here, I will take this area, but from different angle. At the end, I can have the 3D model. Okay. Then, and what's the percentage? The percentage will be 60% overlapping from each picture. What is important? I will show you the video.
I have a quick question. The 60% overlap, is that because of the angle of the cameras, or is that something that in your field you try to get?
No, the angle of the camera.
Angle.
Then here we have want this point to take picture for them. Then we'll take the pictures by aircraft with overlapping of 60% there.
Wow.
Take pictures for all the area. Then mosaic the pictures to cancel the overlapping between pictures to make it one. This is the overlapping here. We have an object here, the same here. We must have it at one picture. This is the different angle to have the 3D model.
Wow.
Then for whole the area, we must put the mosaic as I said.
So you apply the same thing to each one.
Yeah. And then at the end we can find the 3D model from the different angle from the same object. This is what they want to say.
Wow.
Okay, then we have the remote sensing. I will define the remote sensing as a science of obtaining information about the area of phenomenon by device which is not in physical contact with the object, because we will take pictures here from satellites. First, photogrammetry from aircraft, here from satellites, because we want to cover a big area. And with the area or phenomenon. Here the picture that comes from the satellite. Okay, here the Earth, and when we take the pictures from the satellites, we can find it like this, many different colors. And what can we see in this color, this picture, like here? We can find if we have underground water, or we can find if what kind of soil here or sand here, and what plants can grow in this area. And resolution and accuracy. The resolution about this, it's very good, but it's far from the Earth. Then it will be less than the photogrammetry and the land survey. Land surveying. It's to take measurement from the Earth by devices upon the Earth. Like the measurement, it's defined like this: the measurements of the dimensional relationship as horizontal distances, elevations, angles, and directions on the Earth's surface, especially for use locating property boundaries, construction layout, and map making. To save everyone state, we use total station for take the dimensions. And this is some people ask me about that on the street, and they said like it's a camera. It's not a camera. It's a device to take many dimensions and angles. And this device has laser, and it comes with reflector to reflect that laser. And here we put the device, the total station, in the middle of the boundary or state, and the man will be around the boundaries on the edges to take the reflection from the laser. We need to have two people here. Okay, the most important question here. What are the differences between photogrammetry, remote sensing, and land survey? I will say first by. Here, photogrammetry by aircraft. Remote sensing by satellite. Then land survey on the Earth by devices. Then the accuracy and the area. The area will be, for the land survey, will be small area, like state or boundary. Then photogrammetry will be from bigger area, and remote sensing bigger and bigger area because it's from satellite. And accuracy. Mistakes are likely to happen when you are further from the Earth. Then, the best accuracy for making measurement is lens replay. Then, finally, the GPS. It stands for Global Positioning System. And the definition is a system which signals are sent from satellites to a special device used to show the position of a person or thing on the surface or the Earth. Here, everybody say like I have a GPS on my mobile. No, it's a device or receiver, and the whole system it's GPS. Okay, system needs. First, we need device, like it's an app in your